Okay, this is going to be the advanced math review for 2017-2018 on exponentials. This first part is just converting from a log to an exponential or an exponential to a log. So whatever the base is what you keep. Put the equal sign in the same spot. And basically these two things move locations. That would be a 2, that would be an x. From going the other way, the base here would be 7 for a log. Okay, and then these two things are going to go opposites parts. So that's 49, all right, -2. Okay, all right. This one right here, all right, my base would stay x. All right, the 3 would come over, the 64 would be there, so they would swap places. And then this one would be log of 2, all right, and then the 6 and the 64 swap places. So 64 over, and then 6 right there. So that's the first section on conversion, okay? Expansion, depending on who your teacher is, whether they'll ask you to expand or not, okay? So the idea is if things are multiplied, then what happens is they will be turning into addition. And if you have any exponents left over, they come down. So that would be log 4 with 5, 2 log of 4x. This would just be pretty simple. Would be, it would start out log of 3, all right, x to the 7th plus log of 3 y squared minus log of 3 z to the 6th. And now all these numbers come down. So it would be 7 log 3 x plus 2 log 3 y minus 6 log 3 z. Okay? This one right here, this is going to be natural log of 5 plus natural log of x to the cube root. Another way of writing that is the 1/3 power. So that 1/3 would come down. So you'll have natural log of 5 plus 1/3 natural log of x. Okay? Ask your teacher whether you're going to do expansion or not. All right? In my class, we only do the condensing because it only helps us solve the equation. Okay? So for this one, what you do first is you move the exponents. So what I got is natural log of x to the 1/4 minus natural log of y to the 1/2, and subtraction turns into division. So that's natural log of x to the 1/4 divided by y to the 1/2. If you're doing roots, that's 4th root. You're doing that at square root. This, the 8 moves back and the 5 moves back. So it's x to the 8th plus natural log of y to the 5th. Addition turns into multiplication. So I got that times y to the 5th. Okay? Same thing here. The 7s, 8s move up, and the 10 moves up. Okay? So that's going to be log x 7 plus log y 8 minus log z 10. Okay? So what I got is I'll have log, the x to the 7th and the y 8 will be up top through multiplication, and z to the 10th will be on the bottom. Okay? So the big thing is subtraction turns into division, addition turns into multiplication, but move your numbers first. Okay? Moving on to this one. Now, if you've got your good calculator, this is pretty easy. The big thing you got to understand is that n means compounds in a year. Okay? And then when you have the r, for instance, this is 12%. But let's say you have a rate of like 4%. You got to make sure you write that as 0.04, not 0.4. Okay? So find the balance of your account if it's compounded annually. Okay, so I'm starting with $4,000. 1 plus, my rate is 12%. All right, since it's annually, that's going to be 1 for that, and then this exponent will be 1 times the number of years, which will be 15. Okay, if you're using your calculator, the gray one, use your nice fraction button for this. Okay, now I'll show you the calculations on my calculator. It's a little bit different than yours. All right, I don't have the fraction button. Okay, so I would do 4,000. Okay, 1 plus, all right, 0.12 divided by 1. Okay, raised to, and I got to put parentheses, 1 times 15. Okay, so that's 2185. I'm just going to check this real quick on the gray calculator to make sure that that is correct. Exponent 1 times 15. Yep, that is correct. 21,894. And how many cents? 26 cents. Okay? If it's compounded monthly, the only thing that's going to change in this is that I am going to divide by 12, and then 12 goes up into there, okay? So I'd have 4,000, all right, 1 plus 0.12 divided by 12 raised to the 12 times 15. Once again, you don't have to do the parentheses there. All right, 23,983 and 20 cents. Okay, all right, compounded continuously. When you do it continuously, you do the PERT. So I'd be at 4,000. E, the rate is 0.12, and it's 15 years. Okay, so 4,000. Okay, E raised to the 0.112 times 15. Okay, that is going to be 24198 and 58 cents. Okay, if they ever ask you compounded quarterly, that's obviously 4 for N. Okay, all right, so those are pretty simple. All right, moving on to these problems. Okay, what you have to do in this is you treat this, the number of bacteria or organisms is Y. This you treat as X. So what I would recommend you do for each problem is ask what you're finding. So it says how many organisms. So they want me to find Y. This will have relevance in a second. How many organisms? Find Y. How long? Find X. So the unknown is what you're finding. Okay, so what I want to do with this is I'm going to go into the calculator and I'm going to go to graph. Okay, I'm going to put 20, shift. The E is located right here on the natural log button, which is a couple up from the 9 key. All right, and I got 0.2 X. All right, so I'm going to use X instead of Y. All right, so when I draw it, all right, first of all, my calculator's not reset. You do that hitting F3 twice, exit draw. Then I'm going to zoom out, execute. Zoom out, execute. Zoom out, execute. I do that 3 times. Then I go to GSolve. I scroll, which is F6, and then what I'm finding is the cal. So I do YCal. So the first thing I want to calculate is when it's 0. That's going to be 20. I want a YCal, so GSolve YCal when T is 2. That's 29.8. And I want to find X, and I'm going to put in 1200. GSolve, I'm going to do an XCal, and I'm going to put in 1200. So I recommend, and you get 20.4. What my recommendation is to write down those things, because that will dramatically help you. Okay? Moving on to the log and exponential equations. Okay? This one is sort of the only one that's really unique. You have an exponent on both sides, so you're going to take the natural log to both sides, and what that does is move these down. So I got 2x plus 3, all right, times the natural log of 2, and x minus 4 times the natural log of 8. Okay? Natural log of 2, and this is just going to become a battle of decimals. The natural log of 2 is 0.69, okay, all right, times 2x plus 3. And on the other side, I got natural log of 8, which is 2.07 times x minus 4, okay? So I'm going to multiply there, all right, and just watch your decimals. Okay, it's going to be 1.38x plus, all right, 2.07, okay. All right, I've got natural log of 8, which I believe is 2.07 as well. It's sort of weird that end up happening. Okay, so 2.07 times x will be 2.07x, and then negative 4 times 2.07, okay, is negative 8.28. All right, I'm going to extend my page. Hopefully it lets me. All right. So then what I want to do is I want to subtract 1.38. You can do it a lot of different ways. Okay, there's not one right way to do it. Okay, as long as you make sure whatever you're doing on one side, you're doing on the other. Okay. Okay. All right, I'm going to add. All right, it's 10.35. Okay, and then I'm going to divide. Okay, this one is literally a battle of decimals. All right. Ends up being 15 for my answer. All All right, so long way to get to 15. Okay, on this one right here, let me make sure it's still running, everything looks good. Okay, all right, what I want to do is I want to make sure this is isolated, which it is. So then I'm going to take the log, I'm going to convert this to a log, so it'll be log of 6. The 156 comes over, and the 3x plus 5 goes to the other side. That's why you learn that. Now, on the gray calculator, what you want to do to get this is go to Option, okay? Option, then Calc, which is F4 on your gray calculator, okay? Then you scroll, which is F6, and then you choose the Log AB button. All right, that's how you get to the log from that screen, which is F4. All right, so if I choose that and put this in, all right, I get 2.81. All right, and now I'm just going to solve the equation by subtracting 5. Okay, so 2.81 minus 5, I get negative 2.19 equals 3x, and I divide by 3. All right, that's negative 0.73. And that goes right here. All right, pretty simple. Okay, this one, I want to combine as a single, so subtraction turns into division. All right, now if I've got natural log, I want to make these powers of e, because what will happen is that will cancel out, and I'll be left with x over 4. E to the 5th is 148.41. What I'm going to do here is I'm going to move that up through multiplication. Okay, so 148.41 times 4, that's 593.64. Okay, this one, I want to isolate this. So what I want to do is I want to divide by 5 first. So I got log of 4, x minus 1 equals 3. Okay, now I want to convert this to an exponential. So that'd be 4, the x minus 1 goes over, 3 goes over there. So 4 to the 3rd power is 64 equals x minus 1, and then I just add 1, and I get 65. Okay? This one, I want to isolate the e, which has already been done, so I'm going to do natural log of both sides. Now, what happens there is that ends up canceling that part out, so you're left with 3x equals, I figure out what the natural log of 100 is. Natural log is located where the e is. That's 4.60. And I'm going to divide by 3. Okay? All right, 4.60 divided by 3 is 1.53. Okay? This one, I've got to isolate this, so I've got to get this away by subtracting 7. So natural log of x minus 4 equals 2. Now, since it's natural log, what I'm going to do is I'm going to make these powers of e. So what happens is this goes away. I'm left with x minus 4. I figure out what e squared is, so shift natural log, e squared, 7.38. And then I'm going to add 4, and that's going to give me 11.38. Okay? All right, pretty simple there. All right, moving on to the last 3 problems with the solving. Okay, this one, just like the natural log, this is going to turn into division. So I got log of 2, x plus 5, divided by x minus 2 equals 3. Now, what I want to do is I want to convert this to an exponential. So that'll be 2 base 3 equals x plus 5 over x minus 2. Okay? Well, 2 to the 3rd power is 8. So I got, move this up here. I got 8, all right, equals x plus 5 over x minus 2. So here's the trick here. You got to move this up here. So what I'm going to do is I'm going to distribute that. So that's going to be 8x minus 16 equals x plus 5. I'm going to subtract x. So that gives me 7x minus 16 equals 5. Add 16. Okay, so 7x equals 21, and divide by 7. It's a little messy. X equals 3. Okay, so the big thing is knowing to write it like this with the division and to bring this up and distribute it. Okay, this one I'm going to isolate e, and I got to do that by subtracting 5 first. So I get 12. Then I want to get rid of the 2, which is division. Okay? When I have e, what I want to do is I want to take the natural log of both sides. Okay, so that crosses that out. I'm left with x minus 4. I figure out what the natural log of 6 is, which is 1.79. And I'm just going to add 4 to that, which that would be 5.79. Okay? And then this last one. This is already isolated, but I'm going to have to turn that into an exponential. So 3 to the 4th equals 5x. Just switch those. Okay, 3 to the 4th equals 81. And then I'm going to divide by 5. 81 divided by 5 is 16.2. Okay? All right, so that's those solving equations. Now moving on to the graphs. Okay, what I'm going to look at first is understand that when I have an exponential, I'm only going to have an asymptote that looks like that, and it's going to be y equals. And whatever my anchor point is, that will tie into what that number is. So here, my anchor point is -3, -4. So I consider this the inside, outside. So what I always want to do is opposite. So -3, 1, 2, 3, 1, 2, 3, and 4. So I'm going to go ahead and do this. And I already know this answer. That's y equals -4. And that will be important when I get to my graph. So what I want to do to actually graph it, I'm going to go into the table. All right. And I'm going to go 2 exponent. I got to use parentheses. You do not. X plus 3 minus 4. All right. And what I want to graph, this is where it's a little bit unique. I want to graph -3, -2, and -1, -4, and -5. You're going to even graph this one because that's going to create your curve. So I do -3. That's -3, -3. Okay. -2 I put into the table. And I get -2, -2. And then I put -1 into the table. I get -1, 0. And then I put -4 into the table. And I got -4, 3.5. And then I put -5 into the table. And I get -5, -3.75. So here's what it looks like this. Now, the key thing is in labeling the arrows. The arrow closest to this dash line will get that coordinate, which is -4. So y, y. Then the rest is -infinity. All right, this will be positive, positive. If I'm doing domain, smallest x is -infinity, biggest is positive. For range, my smallest y is -4, and my biggest y is infinity. I keep that a curved bracket because I got that from that line. Okay? Moving on, I think this is the last couple. All right? I think it's, yep. I don't know if I have a graph for that one. Okay? So this one, you're going to go and your anchor point is going to be 1, -5. Now for log, you have an x equals asymptote. Okay, so I'm going to have x equals, in this case it will be 1. Okay, so 1, 1, 2, 3, 4, and 5, like this. Okay, and when you go into your calculator, you get a menu and table. Okay, and you go to option. Calc, log AB, and I put in 3, I put in x minus 1, I put in -5, okay? And then I'm going to try to put in 1, 1 doesn't work, 2 gives me 2, -5, 3 gives me -4.3, all right? If I try the other ones, okay, I don't have those other ones that will work. So 1, 1, 0, and -1, they don't work. What you have to know is that the log is going to look like that. And so this is x equals 1, so this would be 1 and -infinity. This is positive and positive. So your smallest x is 1, biggest is infinity, smallest is -infinity, biggest is positive. If you go to graph, you can find these things, okay? So you draw it, okay? All right, g solve root, I think this is going to be none, okay? And then this is also going to be none for y-intercept. Okay? Moving on to this one. Okay? That anchor point is going to be at 0, 6. 1, 2, 3, 4, 5, and 6. I got a dashed line, which would be y equals 6. Alright? Then what I'm going to do for values is I'm going to grab 0, 1, and 2, -1, and -2. Okay? All right, so negative 3 to the x plus 6 table. All right, 0 puts me at 5. 1 puts me at 3. And 2 puts me at negative 3. Okay, and then negative 1 puts me at 5.6. Okay, and then negative 2 puts me at negative 5.8. So this is my graph. If I'm labeling my arrows, this would be 6, negative infinity. This is positive, negative. So for my domain, I'm negative infinity to positive. And for my range, I'm negative infinity to 6. All right, if you go to graph and draw it, all right, G solve root 1.6, and G solve y-intercept, y equals 5. Okay, and for the last one, if you want to graph that, that's going to be the anchor point would be 0, negative 4. Okay, your asymptote's going to go through that. Okay, and when you graph it, just to save some time, it's going to end up looking like this. Actually, we want to do the solid line. Okay, so once again, you go into your calculator and you put that in. You graph. What you would graph is you graph the points 1 and 2 will be the only ones that will work. These other ones will not. So if you go through your sample test, you should be fine.